Self-introduction, my name is Steve Thur, and I am the Assistant Administrator for Oceanic and Atmospheric Research at NOAA, and I am also the agency's Acting Chief Scientist. The Arctic Report Card, now in its 20th year, brings together 112 authors from 13 different countries, and each one of those professionals is dedicated to monitoring and understanding changes in the Arctic. Yes. This international collaboration tells a story of sustained environmental change in one of Earth's most sensitive regions. And I think this file, what we are releasing today, is a true testament to the power of collaboration. I want to thank those members of the press that are here with us today, both in the room and online, for the rollout of the Arctic Report Card. As was noted in the video, that at least those in the room could hear, the Arctic continues to warm faster than the global average, with the 10 years that comprise the last decade marking the 10 warmest years on record. Changes in this region affect the US weather and valuable fish supplies that provide seafood nationwide. One symptom of these changes is Atlantification, an influx of warmer waters and marine species from lower latitudes, which now reach the central Arctic Ocean hundreds of miles beyond the former boundary of the Atlantic, excuse me. On land, thawing permafrost is altering ecosystems, turning over 200 watersheds in Arctic Alaska orange as iron and other elements are released into its rivers. This 20th anniversary file highlights the critical value of sustained and collaborative observations for understanding and responding to rapid change in the Arctic. In the past year, NOAA has sustained comprehensive Arctic observations in ecosystem science, tracking sea ice, ocean and atmospheric conditions, and biological productivity through networks like the US Arctic Observing Network, the Distributed Biological Observatory, and EcoFOSI, a national oceanic and atmospheric supported research program to monitor ecosystems of the Bering and Chukchi Seas. NOAA has also supported fisheries and marine resource management, gathering critical data on fish, crab, and shellfish populations to manage both healthy fisheries and to support coastal and subsistence communities. And finally, we've delivered advanced Arctic forecasts and new models that improve predictions of sea ice, weather, ocean conditions, and ecosystem shifts, providing information for policymakers, those in private industry, and local communities with actionable tools for planning. And with that, I'm going to pass the figure of mic to Matt for the panelists' comments.
Thank you, Steve, and good morning, everyone. My name is Matthew Druckenmiller. I am with the National Snow and Ice Data Center at the University of Colorado Boulder as part of the Cooperative Institute for Research in Environmental Sciences. And on behalf of our editorial team, including Twyla Moon here at the table, Rick Toman online, and our coordinating editor, Mary Beth Armstrong, I want to thank everyone that's contributed to this year's Arctic Report Card. I also want to give my sincere thanks to the Arctic Research Program within NOAA's Global Ocean Monitoring and Observing Program for the fantastic video that we saw, the website, and all the graphics that comprise the report. I'm honored to be here with this panel today to share many of the key headlines for this 20th edition. The Arctic Report Card truly is an international collaboration, and over the last 20 years, we've seen a lot of the foundational partnerships for the report card strengthen. We also have greatly benefited from the increasing contributions from Arctic Indigenous peoples and Arctic residents, both to better understand change and to understand what it means to live on the front lines. The Arctic Report Card is organized into 3 sections. We have our 8 vital signs, which we track every year. Other important topics are updated periodically as indicators. And this year we look at glaciers and ice caps outside of Greenland, the Atlantification of the Arctic, and warming waters and borealization. Borealization refers to the movement of more southernly non-Arctic species into the Arctic waters. Other emerging topics are covered as frostbites, and this year we have a contribution focused on the Indigenous Sentinels Network on St. Paul Island, as well as the observations of Ruston Rivers. Within this 20th anniversary edition, we also have an assessment of the state of the Arctic Observing Network. Let us start by first acknowledging that the warming of our planet driven by human greenhouse gas emissions into our atmosphere is amplified in the Arctic. The Arctic continues to warm much faster than the globe overall, amplified by the loss of reflective sea ice and snow, causing more of the sun's heat to penetrate into land and ocean. This past year, as Steve mentioned, October 2024 through September 2025, the Arctic experienced the highest temperatures on record since at least 1900. This included the warmest autumn, the second warmest winter, and the third warmest summer ever observed. Warming ocean waters are clearly linked to these increasing air temperatures. In 2025, August sea surface temperatures in most Arctic regions ranked amongst the warmest on record since records began in 1982. We see warming trends in almost all regions of the Arctic that are ice-free in August, with increases of more than 0.5 degree Fahrenheit per decade. This warming alters ecosystems and is a prime driver of sea ice loss. The maximum sea ice extent in March 2025 was the lowest in the 47-year satellite record. In September 2025, the minimum sea ice extent was the 10th lowest on record. We also observe the thickest, oldest ice, the ice that's more than 4 years old, has decreased by more than 95% since the 1980s. This thinner ice is then much more mobile with wind and current and much less resilient against warming waters. This means much more unpredictable ice conditions for those both living and working in the Arctic. Sea ice loss is also driving changes in ocean primary productivity, which is the rate at which marine algae converts inorganic carbon into organic material, forming the base of the marine food web. Since regular observations began in 2003, primary productivity across the Arctic has increased in almost all Arctic regions, with increases as nearly as high as 80% in the Eurasian Arctic. Increases in primary productivity at the wrong time of year can threaten ecosystems by creating misalignments between when the food is available and when species that depend on it are able to feed. This disrupts the overall food chain. Increases in primary productivity also increases the likelihood of harmful algal blooms, which introduce toxins into the food chain, as well as create risks for Arctic coastal communities. Now with that, I'm going to turn it to Gabe, who will discuss further changes in the ocean, as well as changes in land ice.
Thank you, Matthew, and good morning, everyone. I'm Gabriel Wolkin with the University of Alaska Fairbanks. Today, I'll summarize 3 chapters that together reveal how quickly the Arctic climate system is changing, from the deep ocean to the Greenland ice sheet to the glaciers and ice caps scattered across the Arctic. We begin in the Arctic Ocean, which is undergoing Atlantification, the intrusion of warmer, saltier Atlantic water and biota into its central basins. Historically, this deep, warm water was blocked from the surface by the Arctic halocline. That barrier is now weakening. As a result, Atlantic heat can easily mix upward, rapidly eroding sea ice. This creates a process that is fundamentally altering the Arctic's thermal structure and reshaping entire ecosystems. This deep ocean warming interacts with other components of the Arctic system, including the region's largest ice body, the Greenland ice sheet. The Greenland ice sheet holds enough ice to raise global sea level by 23 feet, and it continues its long-term pattern of net loss. In 2025, Greenland lost 129 billion tons of ice. The resulting meltwater added 0.01 inches to the world's oceans. As a result, Greenland remains in sustained decline, adding sea level rise and influencing ocean circulation patterns in the North Atlantic. Beyond Greenland, the most sensitive ice is found in the thousands of glaciers and ice caps scattered across the Arctic. Arctic glaciers and ice caps make up 60% of the world's mountain ice, and they're losing mass at an extraordinary rate. In 2024, the last year for which data are available, all 25 monitored glaciers melted faster than they accumulated snow. Conditions were especially severe in Arctic Scandinavia and Svalbard, both of which set new records for ice loss, driven by temperatures, record-breaking high temperatures. Long-term trends show the same pattern. Alaskan glaciers have thinned by over 125 feet since the 1950s, and the annual rate of mass loss in the Arctic has tripled since the 1990s. Annually, the loss of 181 billion tons of ice from glaciers and ice caps has contributed nearly half an inch to global sea level rise over the last 20 years. But the most immediate consequences are local. Rapid glacier retreat is undermining water security for some Arctic communities and creating significant hazards. For instance, glacial lake outburst floods are becoming more frequent and in some cases larger in certain rapidly deglaciating parts of the Arctic. In steep terrain, glacier retreat combined with slope instability can lead to landslides, far-reaching tsunamis. The August 10th, 2025 landslide in Southeast Alaska's Tracy Arm illustrates the sheer power of these hazards. The slide generated a tsunami that swept across the narrow fjord and ran nearly 1,600 feet up the other side. Taken together, the evidence is clear. From the deep oceans to the highest peaks, the Arctic cryosphere is undergoing rapid, interconnected, and unprecedented change. And those changes matter far beyond the Arctic. I'll now turn it over to JJ Frost, who will discuss precipitation, terrestrial snow, and tundra greenness.
Thank you, Gabe. Everyone. I'm JJ Frost, vegetation ecologist at Alaska Biological Research in Fairbanks, Alaska. Let's turn our attention now to three Arctic vital signs on land. First, tundra greenness. Earth's northernmost continental landmasses and island archipelagos are home to the Arctic tundra biome, which forms a living wreath atop the globe that encircles the Arctic Ocean. Tundra landscapes support an array of low-growing shrubs, herbs, mosses, and lichens adapted to long winters and short but intense growing seasons. Tundra habitats support Arctic wildlife, ranging from large mammals such as caribou and muskox to a diverse array of migratory birds that each year connect the Arctic with every corner of the globe. Tundra vegetation also plays a key role in insulating permafrost, which preserves vast stores of organic carbon that are of crucial importance to the global carbon cycle. The warming atmosphere and concurrent declines in permafrost, seasonal snow, and sea ice that have been documented over the 20 years of the Arctic report card are profoundly reshaping tundra ecosystems. As a result, conspicuous landscape changes have occurred within living memory of Arctic residents. And since 1982, we have been able to track the changing tundra biome at the circumpolar scale through the lens of Earth-observing satellites. Satellites take advantage of the unique way in which plants reflect visible and infrared light and provide a yardstick of vegetation productivity we term tundra greenness. The satellite record of tundra greenness has entered its 5th decade and provides foundational information concerning ecosystem conditions and responses to the changing Arctic environment. In the late 1990s, a systematic increase in tundra greenness became evident that has come to be known as the greening of the Arctic. Arctic greening remains prominent in all long-term satellite data sets, aligning with increases in the cover, stature, and productivity of tundra vegetation documented on the ground. Common shifts, such as a general increase in tundra vegetation height and the northward spread of shrubs and trees, portend changes in the habitats that support Arctic wildlife, and in turn, changes in the subsistence resources on which many Arctic people depend. In 2025, satellites documented yet another year of high tundra greenness that was exceptional by historical standards, continuing a sequence of record or near record high values. Long-term greening has been especially prominent in the North American Arctic, particularly Alaska, a pattern further reinforced by the 2025 growing season. Taken together, the satellite record, an array of field studies on the ground, and the knowledge base of Arctic peoples provide compelling evidence of ongoing and profound change in the living Arctic. Next, precipitation and snow cover. An intensifying hydrologic cycle driven by increased evaporation, precipitation, and meltwater production continues to emerge as a central expression of the persistent heating in the Arctic. Circumpolar average precipitation set a new record high for the most recent water year, representing the period from freeze up in fall 2024 to the end of the most recent thaw season this past September. Precipitation totals for the fall, winter, and spring seasons were all among the top 5 highest on record since 1950. Nonetheless, this summer was unusually dry, especially in parts of Arctic Eurasia and Canada. But overall, these patterns are consistent with more moisture in the atmosphere and an increasing frequency of extreme precipitation events, including atmospheric rivers, which can deliver heavy amounts of rain and snow to large regions across the Arctic. Arctic landscapes are typically covered by snow for over half of the year. The winter snowpack and the timing of spring snow melt shape the growing season for Arctic vegetation, and the highly reflective snow is also one of the main ways that Arctic conditions connect to the global climate system. Snow cover on land is directly influenced by increasing Arctic precipitation, while at the same time, the reduction in snow cover duration amplifies Arctic warming. And 2025 was a clear example of this. While the winter snowpack was above average across much of the Arctic, rapid melting in late spring caused June snow extent to drop below normal, continuing a 6-decade decline. June snow cover extent is now half of what it typically was in the 1960s, altering river discharge, tundra vegetation, animal behavior, and fire risk. The loss of reflective snow surfaces in June, when incoming solar energy reaches its annual peak, results in more heat absorbed at the surface, contributing as a feedback to Arctic warming. Now, I'd like to turn this over to Abigail Pruitt, who will speak about the phenomenon of resting rivers.
Thank you, JJ, and hello, everyone. My name is Abigail Pruitt, and I'm a postdoctoral researcher at the University of California, Davis, where I study resting rivers. In Arctic Alaska, over 200 streams and rivers have turned a rusty orange color, termed resting rivers. Most of these changes have been observed just in the last 10 years, coinciding with a dramatic increase in air and ground temperatures. Evidence suggests this rusting is due to thawing permafrost soils. As the ground warms and thaws, groundwater is routed through deeper soil layers where it can interact with mineral deposits. Those minerals are then carried into adjacent streams, a process called acid rock drainage. The orange color in these streams comes specifically from oxidized iron, but in addition to iron, we're seeing elevated acidity and toxic metal concentrations like zinc, copper, and aluminum. Mounting evidence illuminates the need for expanding research efforts to better understand the causes and consequences of resting rivers. Resting rivers are common in the continuous permafrost zone and in alpine and rocky watersheds of the Brooks Range where sulfide minerals like pyrite are present. From observations in the Brooks Range, we observed that for some streams, the rusting occurred one year, but the stream ran clear the next year. But for others, we observed that rusting persisted each year and in some cases even got worse. It is currently unknown what drives these patterns of discoloration, but the abrupt increase in the number of resting rivers, as well as the fact that these observations span more than 1,000 kilometers from east to west, strongly suggest that regional climate drivers and widespread permafrost thaw are contributing to their emergence. Last year in 2024, permafrost monitoring sites in North America and Norway saw their highest temperatures on record. As the Arctic continues to warm, this phenomenon is expected to continue, with significant consequences for water quality, aquatic biodiversity, and the communities that rely on these streams. Arctic rivers provide habitat for a broad array of fish, many of which are critical for subsistence, sport, and commercial fisheries. Within Kobuk Valley National Park, we observed the complete loss of juvenile dolly varden and slimy sculpin in a tributary to the Akillik River when it turned orange. In addition to the loss of fish, there was a steep decrease in invertebrate diversity and algae in the stream as well. While the exact underlying cause for this decrease in biodiversity are unknown, water from many resting rivers exceed chronic metal exposure criteria established by the U.S. Environmental Protection Agency. Beyond the effects on fish, resting rivers may impact drinking water supplies to rural communities as well. Some concentrations of metals, such as cadmium, nickel, and manganese, exceeded either EPA drinking water criteria or World Health Organization guidelines in these orange-colored streams. The documented presence of these metals presents a challenge to drinking water access in remote Alaska. These findings of water quality degradation in northern Alaska have broader implications for the circumarctic region and waters draining landscapes undergoing permafrost thaw and deglaciation. Other studies have documented rusting and metal mobilization in watersheds undergoing mountain permafrost thaw or glacier melt, including temperate regions of the Alps and tropical regions of Peru. These global observations point toward the broader loss of permafrost as an issue driving water quality impairment and the need for continued research to better understand the causes and consequences of this emerging environmental issue. And now I'd like to turn this over to Hannah Marie Ladd.
Thank you, Abigail. Hello, everyone. My name is Hannah Marie Ladd, and I work for the Aleut community of St. Paul Island Tribal Government as the director of the Indigenous Sentinels Network. And before I begin, I want to be clear about my positionality. I am mixed Hispanic and Indigenous with ancestry stemming from the Lakotas peoples, but I am not a Nungan or from St. Paul Island. However, I am honored to serve the Aleut community of St. Paul Island's tribal government and their Environmental Research and Economic Development Department. One of the chapters I'm sharing today reflects a lot of their leadership, priorities, and governance. I'm also highlighting another chapter from this year's report. The first chapter is on warming waters and borealization, written by another author, which makes something very clear. Borealization is not just a land-based process. It's happening in the ocean and it's accelerating rapidly. 3 points from this essay stand out to me. The first is that the northern Bering Sea and the Chukchi Seas are warming faster than we've ever recorded. Combined with ongoing sea ice loss, this is fundamentally reshaping where species are found and the ecosystem's functions. Second, while southern species are moving north, Arctic species have declined dramatically by about 2/3 in the northern Bering Sea and half in the Chukchi. That's not a subtle shift. It's an entire reorganization of an ecosystem. And third, and most importantly, these changes cascade directly into people's lives, affecting fisheries, coastal safety, and subsistence harvests. This impacts food security, not just locally, but nationally, and it impacts our culture and community resilience. The larger message from this chapter is that we are no longer just documenting warming, we are witnessing an entire marine ecosystem, which is tied to our economies and culture, transform within a single generation. And that brings me to the second chapter, highlighting our work on St. Paul Island. For more than 20 years, the Aleut community of St. Paul Island tribal government has built and operated its own Indigenous-led observing system called ISN. ISN was created because the tribe needed a way to support co-management and research in the region. So the tribe didn't just adopt a tool. They built their own entire system, from the database to the mobile app to the data governance. And this is just one example of what data sovereignty looks like in practice. Community members aren't just collecting data. They're analyzing it, using it to make decisions, and they're storytellers. Sentinels, or our community observers, monitor what matters locally while working alongside research priorities. They're trained to design, run, and interpret monitoring across wildlife, storm observations, coastal erosion, fisheries, contaminants, weather, and more. Our chapter highlights one project in particular, the Braided Food Security Project, which builds local capacity and workforce to monitor mercury contamination in traditional foods using our recently established and tribally owned laboratory at the Bering Sea Research Center. This year, we collected and analyzed over 100 samples of subsistence foods for mercury right on the island. The third takeaway from our chapter is that this turnaround time and trust between researchers and the community is very important because the tribe owns the infrastructure systems and invests in the methods to build local capacity. The observations and data can move quickly into decision-making. And finally, this model is scalable and transferable. What's happening on St. Paul Island offers a model for resilience and collaborative research everywhere, especially from the communities at the front lines of change. So I'll leave you with this. As we've all said, our Arctic is changing fast, often faster than our conventional observing systems can respond. And as we reflect on 20 years of this report card, the lesson is clear. Indigenous leadership, local workforce development, and community-driven observing are not optional. They are essential to understanding the Arctic that we have today and preparing for the Arctic we are moving into. Thank you, and now I'll pass it back to Matthew.
Thank you. Across all what we just heard, the observations that we report in the 2025 Arctic Report Card underscore the pace, scale, and the interconnectedness of Arctic change, including the impact on Arctic peoples and the planet. The recent storm, ex-typhoon Hailong, that slammed into Western Alaska this past October is a somber account of the risks that many coastal communities face in a warming Arctic. Prior to this storm, temperatures in the Bering Sea were well above normal, which contributed to the strength. The storm brought hurricane-force winds, storm surge, and catastrophic flooding, which displaced nearly 1,500 residents from across the region. Still today, these communities are assessing the damage and trying to figure out how to resume their lives. Unfortunately, due to amplified warming in the Arctic that we just heard about, further disruptive changes and events like this storm are expected. Since its first publication in 2006, motivated by the notable Arctic warming already underway at that time, the Arctic Report Card has documented extraordinary ongoing transformation. Sustained long-term observations, together with research and monitoring partnerships, are essential for our understanding and adaptation in the Arctic. For 2 decades, the report card has documented key observations, called attention to emerging topics and priorities for research, and raised awareness so that decision makers can understand the scale and urgency of what we are observing in the Arctic. So with that, I'd like to once again thank our international team of contributors to this year's report, and we'd like to open it up for questions from the press. We have many of our contributing authors at the table in the room as well as online, and I'll help to best direct questions.
We're going to promote a few of your colleagues who are online so that we can allow them to answer questions as well. And just a reminder to reporters, please say your name and who you're writing for when you ask a question. If you're online, drop that question in the Q&A box and we'll alternate between the online and the in-the-room questions. Go ahead, Monica.
Go ahead, reporters, please. Let's do your questions and we'll get going. It's your time now to ask any questions you would like. Go ahead, Grace.
Hi, my name is Grace. I am from EOS and I get to interview you. And my question is for Abigail. So I noticed that the video and you mentioned that scientists are still working on understanding some of the drivers of resting rivers. Can you just give me a little bit more detail about what some of those unanswered questions are?
Definitely. Yeah. So we have there are definitely a few different unanswered questions. We think that this is due to thawing permafrost and acid rock drainage, because it kind of looks a lot like acid mine drainage, which we see in the conterminous US with mines, but we know that that's not what's occurring here, because in so many of these places there is not really a human impact in that area. We also are not 100% clear on what's driving like fish biodiversity loss, because it could be due to these toxic metals that maybe exceed what the fish can handle, but it could also be due to the toxic metals being too much for the algae in the stream, and then the fish don't have anything to eat. And those are just a few of the questions that we're still thinking about.
Now we're going to go to our online reporters for any questions.
We have a question from Yareth Rosen at the Alaska Beacon. Given the Trump administration cuts to climate science, how committed is NOAA to future Arctic report cards? Cuts to NOAA have resulted in reductions of service at the National Snow and Ice Data Center, for example. And there have been deep personnel cuts at the Alaska Fisheries Science Center. And I understand that this is the first year that NOAA did not issue an Arctic report card press release. Is that correct?
This is Steve Thayer from NOAA. What I would say in response to that question is that we're here today, and that we have released the 2025 version. And we've also continued our long-term environmental observations in the Arctic, both with satellite observations, but also our in-situ measurements. And so I think one of the things that the community can rely upon is that our efforts to continue to observe the planet will remain present. It is also accurate that we do not have a press release to share with you this year.
Now we'll go back to the room. Any additional questions about any aspects of the card? This is a chance for you to ask about the science. There's lots in it, lots of stories, and we welcome all your questions. Help you with your stories. Go ahead.
Hi, Eli Kintish with Science Magazine. My question is for Hannah Marie Ladd. Could you say more about the way that the data? Could you say more about the kinds of data that the folks in the community are collecting, and how that drives specifically how that drives decision making?
Yes. So specifically in this Arctic report card article, we are looking at mercury contamination in subsistence harvested species. And I do have an author online. I don't know, I just want to invite if she can chat, if she wants to add in after I answer. But we are essentially using community outreach and a very long-term trusted partnership with the University of Alaska Fairbanks Meadow Lab and University of Anchorage. We've been collecting samples from subsistence harvesteds from seabirds, seabird eggs, marine mammals, halibut, fish, and collecting those and typically shipping them off island to the university to then get tested, and that has resulted in a lot of delays. And so over the past couple of years, this has been a large effort led beyond just me to essentially flip that research model, to essentially put all the infrastructure on island. We received funding and tribal council investment to establish a laboratory, find a mercury analyzer that can actually not use compressed gas, so it's safely to use in a rural community. So harvesters are able to donate voluntarily samples. We've trained a local workforce development coordinator to actually run that himself. And then we're able to analyze those results and get them brown truthed with the researchers virtually. And so those results can turn around a lot faster. So that's what we've really focused on in this report card. But broadly, the network that I direct to, it's very flexible, and we also operate across the state, helping communities monitor any priority they have, whether that's migratory birds, marine mammals, coastal erosion. But specifically for this report card, we focus on food safety and security for mercury contamination.
Now we'll go back to the online, see if there are any questions online.
Certainly. And before we get to those, I just want to remind attendees listening virtually, please, if you have a question, please put it in the Q&A box so that we make sure it doesn't get lost in the chat as we answer these questions. This question is from Cole Van Miltenberg, CUNY Graduate School of Journalism. I'm assuming this is likely for Abigail. Given that permafrost thaw is largely irreversible, is there any way to slow or prevent rusting rivers? How are scientists working to monitor the impact of rusting rivers on drinking water?
It's a good question. So there's not a lot that we know of right now that we can do to necessarily slow this down. What we need right now is more research to be able to say where this is occurring. And, it's not occurring everywhere. So in those systems where it isn't occurring, what's causing it to not occur there? As well as, more research will also allow us to be able to adapt in places where they rely on drinking water from these streams and rivers that are turning orange.
Going back to the room, any questions from the room for our panel? Yes.
Yeah. Molly Henry, the legal Chinese for you. I think the perception in the public is often that the Arctic is an isolated place that is not connected to the rest of the world, but what happens there does affect, the whole globe. Can you just chat a little bit, any of you, about what messages you want to give to the public of how what happens in the Arctic has tangible effects elsewhere on the planet?
Matt, would you like to start?
Sure. I think we covered a lot of that in this presentation. The Arctic is really critical to global climate in terms of how it is able to reflect incoming solar energy back out into the atmosphere. Dramatic changes in spring snow cover that JJ discussed, the dramatic changes over the last several decades in Arctic sea ice really change how that energy is reflected back out, and we're observing so much more. And so that's warming the Arctic, but it's also warming the entire planet. And that's not only in the air, but it's also in warming waters. And with warming waters, we're seeing globally an increase in the strength of storms. There's an example from this October in Alaska that we just shared, but we've seen that warming oceans are increasing storms elsewhere. And then additionally, as Gabe pointed out, the melting of both glaciers and the Greenland ice sheet is contributing to global sea level rise, which presents hazards to coastal regions across the planet.
Anybody else on the panel or the editors want to add to that? Okay. We have a couple more questions online. We'll go back online. Thank you.
Zach Coleman of Politico asks, did researchers experience any political interference or censorship in conveying the role human-caused greenhouse gas emissions are playing in a warming Arctic? And if so, how is that handled?
So we should ask that of the researchers who are on the panel. Matt, you want to take that one again?
Well, I can say that in producing the Arctic Report Card in 2025, we did not receive any political interference with our results. We based this report on the observations from many contributing partners, and we also have worked really closely with the Arctic Monitoring and Assessment Program to conduct the peer review of the report. So what we have issued is a peer-reviewed report on observations not only of 2025, but of recent decades. And again, we saw no interference this year.
Thanks, Matt. We have, any questions from the room? We have a few more online, but any questions from the room? We'll go back online.
Freelance reporter Jonathan Amos asks a question for Abigail. Can you say something about how you gather the data? How many in situ sensors, how many water samples are gathered for lab work? What is the role of remote sensing, et cetera?
Yeah, absolutely. So we are able to get out to our sites usually 1 to 3 times a year, depending on the year. This last year, we were able to get out there in August, and we sampled around 70 sites, which was maybe on the lower end. Normally, we're able to get to the sites and take a water sample from upwards of like 200 different sites in some years. And remote sensing plays a really large role in this project too. That's how we've been able to figure out that there are like over 200 streams and rivers that are turning orange or have turned orange. But we also have in situ sensors at some of the sites as well that we're working on the data with.
We have another question online. I'm going to go there directly.
All right. Evan Bush of NBC News says, I noticed that the authors chose to highlight several monitoring programs that have been cut or are facing cuts. Could you describe how those data changes, SMIS, for example, could affect future reports and scientists' ability in general to observe Arctic changes?
And I'm not sure we have an expert on that, or do we not?
Well, do we have Sandy Starkweather online? So I would invite either Sandy Starkweather, who led the assessment of the Arctic Observing Network, to either comment, or perhaps Walt Meyer, who led the CISSA, might want to comment as well.
Go ahead, Sandy.
Hi, thanks for the question. Yeah, so our essay on the Arctic Observing Network itself was trying to speak comprehensively to some of the risks that the observing systems that support the Arctic Report Card are facing, in some cases due to modernization of satellites and sensors that are already beyond their lifespan, like the SSMIS, and also those that are potentially facing cuts for things like, for example, from the U.S. federal budget. And what we consistently heard, we talked to the subject matter experts across 15 different essays, and what we consistently heard is that these transitions, whether they be for modernization or other reasons, have the potential to introduce inconsistencies into data sets. And so it's really important to focus on the role of specialized experts who help to process these data sets, give them the time they need to make these transitions. Like in the case of the passive microwave, that transition was put on hold to give the experts time to catch up with what they needed to do. And so I think JJ Frost is also in the room. He can speak to some of those issues related to the data sets he described in his essay. And if Walt's in the room, he can speak to the specifics of sea ice. But certainly the impacts are felt and really require a clear focus on the human capacity needed to navigate these transitions and the expertise needed to navigate these transitions in a good way. Thanks for the question.
Did you want to add something?
Sure, I can speak briefly in the context of tundra greenness. You know, I mentioned the satellite record is now about 43 years old, and the legacy system that has been operating on board a series of satellites, NOAA satellites, since 1982. It's the Advanced Very High Resolution Radiometer. And that data set has underpinned our understanding of long-term Arctic greening, basically from the beginning. And one of the data products that requires people power to make this happen. It's not just a matter of having the platform up in space. That has been lost. I mean, that record ended last year. And so I think we do have other systems, more modern satellite systems that do continue to record tundra greenness. But a lot of this, observing the Arctic from space is difficult, requires some triangulation, and it's nice to have multiple sources of data that you can, in aggregate, have a much clearer understanding of the pace and the spatial patterns of change. And that is certainly a significant loss. But I would emphasize that there are more modern systems that are in space now, and it will be maintained into the future. So we'll be able to continue to monitor tundra greenness, but it is a loss to lose that legacy data set.
About 5 questions stacked up online. We'll
Let's
get through
take
as many as
another
we can.
online, unless there's one in the room. If someone in the room has a question, please just raise your hand. Okay, go to the online.
Jen Thornhill Verma, reporting for the Globe and Mail in Canada, asks, authors of the report card were candid about some of their disruptions that they faced this year, cutbacks, funding cuts, job loss. And then there was an extended government shutdown. Can authors speak to how they managed these disruptions this year, or how the process changed this year in developing the report card?
Just Matt, do you want to handle that one?
I can start off and pass it to others to pick up. Certainly, the government shutdown had an impact. The Arctic report card, I think what makes it unique is that we are reporting on observations for the current year, which requires us to be working with data sets that are essentially being processed in real time. And so there was a delay, a pause in processing surface air temperature data for the surface air temperature chapter, and Tom Ballinger's in the room, might want to comment more to that. Ultimately, the government opened up and we were able to incorporate that into the report, but it did present a challenge at the time where we had to scramble to identify additional sources of data. Tom, I'm not sure if you want to elaborate on that.
It's just a little tighter window from the time the data was released until the report card was compiled, but we made it work. So kudos to my co-authors also, their help.
Thanks, Tom.
And I would invite my fellow editors, Twyla Moon, and Rick Toman, who's online, if they have further that they would want to add to this question.
I would just note that the Arctic report card, as you heard in the presentation, I mean, 112 authors, 13 countries. This is not just a US report. This is really an international report. It represents incredible voluntary efforts across many, many different topics and expertise. And this was another year where we saw, again, people stepping up, making things happen, working extra time, and really hustling, because all of us believe that this is incredibly important information, and it's important for the people of our planet to be learning this information as quickly as possible. So bumps can happen, and it's an incredible effort to see how people step up and really try to make this happen. And in this case, here we are.
Thank you, Twyla. Let's see, do we have another question online? Okay.
Andrea Thompson of Scientific American has a question for anyone, but particularly anyone who has worked on the report card since its inception. What is it like to look back on these 20 years of annual checkups and the changes that have taken place over that time?
We don't have anybody here in the room, I don't think, who's worked on it all 20 years. Do we have anyone online who's worked on it all 20 years? I've done the public affairs since 2013, but that's not 20, that's 13 years. But maybe some of the longtime authors or editors would like to speak about it.
Well, I would see if Rick Toman online might want to comment. Rick's been an editor for many years and also is on the ground in Alaska, seeing things unfold, across the U.S. Arctic. And so I would love to hear Rick's response to that question.
Yeah, thanks, Matt. Thanks, Andrea. Certainly, as Matt mentioned, the very first Arctic report card in 2006 was issued because things were changing rapidly, and this need for rapid updates was felt keenly. And that is certainly continued. Now we've seen the changes here in Alaska. It's completely obvious to everyone over a certain age that things are very different now than they used to be. And so I think the value of this long-term annual update, every year does not have a new record, but cumulatively it provides an invaluable resource for where we've been and just a guide to where we're going.
Thanks, Rick. Do we have any more questions? We have a few more, okay.
Anyone in the room first?
Yeah, for the room first. Did you have a question? Sorry, I thought I saw a hand over there. No, it's the room's kind of quiet. Go ahead to the online group there.
Zachariah Hughes of Anchorage Daily News asks, Ms. Ladd mentioned species declines in the Arctic of 2-3. Which species are these, and how attributable are their declines to environmental changes we're seeing from Arctic warming?
I think that was in reference to the warming waters and borealization. Is that author online? Because I summarized that essay, so
It was,
okay. We might have to defer that because I don't know the species specific.
we could hook that person up with that chapter. You got the name right, Sean?
Sorry,
Zachariah Hughes of Anchorage Daily News.
Yes.
Yeah, so that chapter was led by Sarah Wise from NOAA Fisheries Alaska, the Alaska Fisheries Science Center, who's not able to be with us. I think it might be best to direct
Yes.
that question
Go ahead,
to.
send that question to me, monica.allen@noaa.gov, and I'll make sure the Fisheries Service helps out with that. Again, that's Monica, MONICA.allen, ALLEN, @NOAA.gov. I'll help you out, Zachariah.
Quick question about Twyla's title in the chat.
Oh, yeah, people.
Can you just tell us what it is?
Yeah, my title, I'm Deputy Lead Scientist at the National Snow and Ice Data Center. That's part of the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder. Choose how many words you want to put into that.
Time for more questions. I know the next panel folks are coming in.
We do have people coming in. Let's try to burn through 2 more questions.
Okay,
and we'll have
very
to
good. We'll take
send the
the
rest
rest
to
of
you.
the questions. Thank you.
Okay.
Yeah.
Barbara Morin, WBUR in Boston, says, sorry to put Dr. Thur on the spot, but at the release of last year's report card, NOAA Administrator Rick Spinrad said the Arctic changes were, quote, one more sign predicted by scientists of the consequences of inadequately reducing fossil fuel pollution, end quote. Does NOAA stand by the statement from the former administrator?
I think what I would say in response to that question is that we recognize that the planet is changing dramatically. Our role within NOAA is to try to predict what's going to occur in the future by documenting what's occurring today. There is a human role, as our administrator currently, Dr. Neil Jacobs, said during his congressional confirmation hearing, for humans in influencing those changes.
Thank you.
Thank you.
The last question we're taking right now. Go ahead.
The last question for now is from Yarth Rosen, again of the Alaska Beacon. For Hannah, are you able to test for algal toxins on island, in shellfish, or even marine mammals and birds? If not, what would it take to set up such a system?
There are partnerships that are going on with the Alaska Ocean Observing Systems and the Harmful Algal Blooms Network. And we are also currently writing a grant to get that equipment established in the laboratory. So it is something that our community has established as a priority and that we are very interested in expanding on site on the island and through the partnerships that we have.
Thank you very much, everybody. We have one more?
Let's
We
try
have time
to,
for just one more?
Okay.
let's get it
Yeah.
in. Yeah.
Okay. Evan Bush from NBC News again asks, was this report shared with the White House in advance of this press briefing? If so, did the administration request any changes or adjustments to the report or how it was presented to the public?
I can answer that. This report was peer reviewed and we shared it with our leadership at NOAA. I don't know beyond that what happened.
We have no more online questions.
All right, well then I think we'll bring this session to a close.
Yes, thank you, everybody. If you need any help with anything, you can email me. I'm happy to get you materials, videos, anything you need. And thank you for coming today. And your work writing about this is super important because we need to go to know what's happening in this sensitive region that affects us.
Thank you for coming, everyone.